Hi, my name is Jordan Glenn, and I'm the head of science here at SuppCo. Welcome to Science Corner. Today, supplement plot twist. Science has a habit of humbling us. A compound gets studied for one reason, researchers run the trials produce results. Some of those results match the hypothesis, and a lot of them don't. And occasionally, the thing that a supplement doesn't do turns out to be far, far less interesting than what it actually does. So today, I want to walk you through 7 compounds that built their entire reputations on one set of benefits and then quietly revealed something far more interesting underneath. This isn't a story about supplements that failed. It's a story about supplements that surprised us, and some of the best plot twists are honestly still unfolding. So let's start with one that you probably know pretty well at this point, creatine. Creatine has been for decades a gym supplement, full stop. Its reputation was built on explosive athletic performance. More reps, more power output, faster recovery between sets. The research supports that use is solid and has been replicated many times over. I know because I ran some of those studies myself. But here's what the science has been quietly revealing. The brain runs on creatine-dependent energy systems too. Neurons also need ATP, cognitive tasks depleted. Supplemental creatine appears to support brain energy metabolism in ways that benefit memory, processing speed, and even mental fatigue, particularly under conditions of sleep deprivation or metabolic stress. Emerging research is also exploring links to depression and neuroprotection. The brain angle is still developing, but the mechanistic rationale is sound. Creatine isn't a muscle compound that happens to affect the brain. It's an energy compound that works wherever energy is needed. Number 2, magnesium. Most people think about magnesium as an electrolyte. The use cases have historically been physical, muscle cramps, constipation relief, maybe post-workout recovery. It's that mineral that you thought about when your calf seized up at 2 a.m. But what the science has revealed is considerably more interesting. Magnesium regulates NMDA receptors and supports GABA activity, 2 of the most important systems in the brain for excitation and inhibition. That neurological role helps explain the growing research connecting magnesium status to sleep quality, anxiety, and mood. The form matters here. Magnesium glycinate and magnesium L-threonate can cross into the nervous system a bit more easily and effectively than the oxide or the citrate forms, which have historically been used as lactives. The electrolyte story is true. The neurological modulator story, I think, is far, far more interesting. Number 3, omega-3s. Fish oil was marketed aggressively as a cardiovascular supplement. The original hypothesis came from population-level research showing that cultures eating large amounts of fatty fish had lower rates of heart disease. EPA and DHA did lower triglycerides. That part held up. The broader cardiovascular protection story, however, it largely did not survive these large randomized clinical trials. But while the heart health narrative weakened a bit, the neurological and anti-inflammatory research kept maturing. DHA is a primary structural component of brain tissue. EPA shows consistent signals in mood and depression research. And the inflammation story evolved into something far more nuanced. Omega-3s appear to support the resolution of inflammation through compounds called specialized pro-resolving mediators, rather than simply just blocking inflammation pathways. So a supplement that wobbled in its original thesis has found a much, much more compelling. Number 4 on our list, vitamin D. Vitamin D research began with a deficiency disease, rickets, the bone-softening condition common in children with limited sun exposure. This was identified as a vitamin D deficiency early in the 20th century. For most of the century that followed, vitamin D was understood primarily through the lens of calcium absorption and bone mineralization. It was what you took to protect your skeleton. Then, researchers discovered that vitamin D receptors are present in a lot of other places. Immune cells, brain tissue, heart muscle, dozens of other sites. That suggested the compound had a far broader role than bone metabolism. Research has since associated vitamin D status with immune function, with mood, cardiovascular markers, and even all-cause mortality. The large-scale VITAL trial found that supplementation reduced cancer mortality and showed signals in cardiovascular outcomes, particularly in populations that weren't already deficient. The bone story is solid, it's settled. The rest of the vitamin D story is still being written, and it's considerably larger. Number 5, one of my personal favorites, berberine. Berberine's historical applications were almost entirely antimicrobial. In traditional medicine, it was used to treat gut infections, diarrhea, and inflammatory conditions of the GI tract. It was essentially a GI compound. That framing persisted well into modern supplement use, but then researchers noticed that berberine activates AMPK, an enzyme that functions as a master regulator of cellular energy balance. AMPK activation improves insulin sensitivity, lowers blood glucose, and even influences lipid metabolism. The outcomes that berberine produces are close enough to those associated with GLP-1 medications that it's really attracted serious clinical attention as a medical health compound. Now, this Nature's Ozempic framing that you see online, it kind of overstates the comparison, but the underlying metabolic biology is real. It's reasonably well supported. Think about this: a gut supplement turned metabolic compound without changing a single molecule. That's a plot twist. Number 6, NAC. NAC's clinical origins are about as far from wellness culture as you can get. In emergency medicine, it's the standard antidote for acetaminophen overdose. It was also used to thin mucus in patients with chronic lung conditions. Neither application has anything obvious to do with the supplement, but researchers began noticing that glutathione depletion and oxidative stress were implicated in a wide range of psychiatric and neurological conditions. That pulled NAC into a very, very different conversation. Clinical research has explored its role in OCD, addiction, bipolar disorder, even schizophrenia, with mixed but directionally interesting results. The mechanism is consistent. Restoring glutathione availability reduces oxidative stress in the brain, which appears to have downstream effects on neurotransmitter balance. NAC is now one of the most pharmacologically versatile compounds in the supplement space, essentially none of which was the original intent. And number 7, glycine. Glycine was the amino acid that didn't have a story. It was a protein building block. It showed up in collagen research because collagen is roughly 1/3 glycine by composition. But even there, it was kind of a supporting cast. Nobody was talking about glycine as a therapeutic compound or any sort of useful supplement. It turns out glycine is quietly involved in several mechanisms that research are very interested in. It acts as an inhibitory neurotransmitter, promotes relaxation, even facilitates the drop in core body temperature that precedes sleep onset, which may explain consistent signals in sleep quality research. It's also a key substrate in glutathione synthesis. And in longevity research, glycine is emerging as a counterbalance to methionine, with animal studies suggesting it may even extend the lifespan by mimicking some effects of methionine restriction. So we went from being completely overlooked to one of the more interesting simple molecules in aging biology. That simple plot twist for a compound that most people have never thought twice about. So here's what I take from all of this personally. I have spent the better part of my career studying supplements. In my academic lab, I wrote papers on creatine, on beta-alanine, on citrulline, compounds that at the time were almost exclusively understood through the lens of physical performance. Muscle endurance, power output, workout capacity, that was the science. And that was the science I was confident in at the time. And I still am. But now we're a decade later, and here's what a decade of research has taught me. Being right doesn't mean being finished. Creatine, the molecule I once studied purely in the context of muscle and strength, is now one of the most promising interventions being explored for cognitive aging. Beta-alanine, which I know as a buffer for muscle acidosis, has now emerging implications for cognition and sarcopenia, areas that had nothing to do with why anyone, including myself, was originally interested in it. Citrulline, which we cared about for blood flow during exercise, has quietly built a legitimate evidence base around men's sexual health and metabolic function. None of these applications existed in any meaningful way when I was running my own lab. They weren't on my radar. If I had stayed anchored to my original thesis or my original frameworks, if I'd held too tightly to these conclusions I'd already reached, I would probably have dismissed all of this as noise. The uncomfortable truth about being a scientist is that strong priors are both your greatest asset and your greatest liability. They help you filter out signals from noise, but they can also make you very slow to recognize when the signal itself has changed. The supplements in this video, they didn't change. The questions we're asking about them did. And that's a reminder that the most important thing is it's not being right. It's staying curious enough to find out when you're not.